Hi, everybody. Today is Monday, November 15th, and we're going to be in Amplify 2.3, but I wanted to speak to you very quickly about the Devil's Tower article. Today is Monday, so we don't really have a whole lot of time to look over those annotations. So I'm going to hold off. We're going to be ready to discuss those tomorrow, and then we're going to also do a second read of a specific paragraph that I want you to look at, okay? So we're going into 2.3, Energy's Role in Forming Rocks. And the purpose of this video is just to kind of review what we did in class today so that you don't have any homework except for to look over your vocabulary words, study those, and study your key concepts. But you don't have to do any of the Amplify. I just kind of want to explain what we did in class today so you're not lost when you come back. So the kids did the warm-up. This warm-up is just kind of discussing again, reviewing what happens in order for magma to melt and what happens in order for rock to weather and create sedimentary or to create sediment. Little bit of additional information that we found out today. Rock has to be as hot as 700 to 1300 degrees Celsius, and obviously that can only happen deep into the earth. So it's just another good reminder that the energy from Earth's interior is responsible for melting that rock. So really we spent the majority of our time today in activity number 2. And we went back to the sedimentary rock. Remember when we made this last Monday? We took sediment, we modeled this. So I had Jolly Ranchers that I had crushed up, and that created sediment. And we put the sediment into the cups. You guys modeled compaction and cementation. And then over time, about a week, it has created sedimentary rock. It is one giant puck, like one hard piece of candy. And then also at their tables, they had a jar with 2 pieces of Jolly Rancher, like the whole candy in it. And that represents igneous rock today. And the reason why we can use that to model is because it's similar to hard candy. Magma is similar to this hard candy because it's made from hot liquid that cools and hardens, just like hot magma cools and hardens to form igneous rock. So what I asked the kids to do is we had these 2 little jars, and I wanted them to model how sediment forms. So before we did any activity, I asked them to make a prediction if they thought that their sedimentary rock, when they shook it, if those rocks would bash together and model weathering and break down into individual little teeny tiny pieces or sediment. And the majority of the kids said, yeah, they thought that would happen. And so then I asked the same thing about the igneous rock. I said, well, do you think the little pieces of igneous rock will clash together and break off and become smaller pieces? And a lot of the kids said, no, they didn't think that would happen. When we actually did it, we had the kids shake the jar for a minute, really, really hard as they could. And when we were finished, then we looked at what was inside the jars, and what we found was both of them created sediment. So what we had in the jars after shaking them was sediment instead of the whole pieces of rock. Is it still the same matter? Yeah, absolutely. If it was sedimentary rock in that jar instead of Jolly Rancher candy, the matter didn't change. It didn't become something else. It's still sedimentary rock. And so now it's sedimentary rock sediment. And the same with igneous. It's still igneous rock. It would still be granite, for example, but then it would be little pieces of granite. It would be granite sediment. So can we make sediment from both types of rock? Absolutely we can. And that's pretty much all we did today. Again, short day, so we didn't have a whole lot going on. But that's all I want to make sure that you know. All right? Let me know if you have any questions, and hopefully we see you tomorrow.